Cool, fantastic stuff. Well, thank you everyone for coming and for joining us this evening. We're now just going to kick off with a few quick introductions. So first things first, welcome to AI and Deep Learning for Enterprise number 17. We are a meetup about all things applied AI. The toilets in this office are weird. For the people in the room, you may have noticed that. For the live stream, sorry, you're going to have to sit through us talking about this for a minute. If you are looking for the toilets in this office, you want to take this door on the left, go down the corridor, take the left by the stairs, then take another left, and then take another left, and the toilets will be right there. It's like that because the door's broken, and instead of it being fixed, they're using the door on the other side.
Has it ever been the case that someone's got lost trying to come back from the toilet?
Yes, people have got lost looking for the toilets in this office. There's also one off the boardroom and the sliding door, but I don't know why anyone would want to use that. If you're really desperate, I guess you've got that as a backup. But that's enough about toilets for one day. Hi, I'm Hugh. I'm going to be one of your hosts this evening. I am a developer advocate at Imply and long-time organizer at Adel. We also have Motzi and Pavel, who are in the room, who are from Daemon, who are our awesome hosts this evening. If you need to find anything like the aforementioned difficult to find toilets, or need to talk to anyone about anything, please do give us a shout. Without further ado, let's get into some quick housekeeping. So, do you want to speak at one of our meetups? Are you doing something with AI and want to talk about it? You don't have to be a world expert. We do lightning talks as well, and we're happy to coach new speakers. So if it's of interest, please do give us a shout. We also have a CFP on Meetup if you want to submit something. We have a code of conduct at all of our events aimed at creating a safe and welcoming community for everyone who comes along, making sure all communication is sort of friendly and professional in tone, and making sure we treat our hosts and venues with respect. For the long version, please do check out the QR code there. Again, also available on Meetup. And if you have any issues, please do come and talk to a host. This evening, we have some really exciting talks lined up for you. So we have Konrad up first, who's talking about the state of AI in 2024. Lucy and Dr. Ariadna from Natwest talking about enterprise scale MLOps, which is super exciting, and we're really lucky to have these guys back. But just before we get started, I'm just going to hand over to Motzi to talk to us a little bit about Daemon.
Yeah, no worries. My name is Motzi Lehata, and I am a senior consultant here at Daemon in our data practice. So who is Daemon? We are a tech consultancy based here in London. Most of our clients, or all of our clients in the UK, most of our colleagues are also in the UK, although we do have some of our colleagues in South Africa. What do? So we have a number of practices, including software engineering, data engineering, and performance engineering. And I am from the data AI and ML practice. So we have a number of different clients. So we have some large corporate clients like Domestic in General, where we do things like set up data lakes, and build we build reporting warehouses. We also do quite a lot of work with startups. So we've done a lot of generative AI work with some of our startup clients. This is our head of data, Ian Ray, up on the board here. See here. Okay, so if you'd like to know a little bit more about what we do, including the generative AI work I just talked about, you can scan this QR code here. This will tell you about how we worked with the company. Well, we worked with a company called Nomi to build effectively a generative AI-powered chatbot that lets you have conversations with historical figures. There's a lot of interesting applications for this. So scan the QR code and give it a read. And if you like that article and think you'd like to join us on a more permanent basis, we do have a number of openings. We're looking for data consultants, engineering consultants, and DevOps consultants. Although we also have a number of non-consulting roles for anyone who's non-technical. So scan the QR code, take a look at our openings, and look forward to seeing you again, whether it's here or in an interview.
Okay, there you go. Hi. So my name is Konrad Bachusz. I'm a lead data engineer at Credera. Today's talk is about state of AI. It's going to be broadly high-level talk without necessarily any technical demos, just to give people an idea of where we are in terms of AI space in 2024. A bit background about myself. So I'm a lead data engineer at a global boutique consultancy. So my work mostly specializes in data engineering, data platform engineering, and AI initiatives for our clients as well. I'm a self-proclaimed AI and data nerd, so I'm passionate about anything to do with data engineering, AI, classical or Gen AI space. In terms of the companies I used to work with, either in consulting or previously working for them, it's mostly in the financial sector, such as Nationwide, HSBC, JP Morgan Chase, currently Lloyds Banking Group, in a mix of basically data roles, analytics, data science, data engineering. If you're interested in following some of my content, you can find me on my tag on LinkedIn or Medium. I would like to make this session a bit interactive, so if you don't mind grabbing your phones and we do a little poll. So the first question really for me to gauge the experience of the audience, I would like to ask you about your experience with AI. So either you are just, a beginner exploring with the technology, finding what can be done, or you're essentially a professional, like, a data scientist, an engineer, data engineer, etc., or you're essentially a trendsetter. You work with OpenAI, or you, a researcher that publishes your own paper about novel algorithms and whatnot that are going to change the world. Okay, yeah, I see a lot of professional experience. It's really helped me to adapt my talk here. A few people are beginners. Quite a few people are trendsetters. Cool, that's really good. Another little bit I wanted to do is to reflect a bit, like, when you think about AI, what's the first thing that comes to your mind in terms of, what is it, what can be done with it, what do you consider as AI in 2024? Let's see some thoughts. Cool, that looks really good. Thank you very much for that. The reason for this little experiment is that I went to a conference at the University of Oxford a couple of weeks ago, and I've met with people who have been in AI for quite a few decades. And it's really interesting to see what was people's perception about AI over the years. Basically, in like 1950s, people used to think that calculators were AI. In the 90s, people think that OCR, optical character recognition, when you take a picture of a text and you can extract, strings, is AI. Nowadays, I don't think many people think about those. Like, people think about GPT, language models, RAG, etc., hype, I definitely agree. But essentially, as a lot of people who work in the field understand that, a lot of this is based on statistics, on mathematics, and, computer science tricks, really, right? Here's a brief history or a snapshot of history of AI. The first neural network started in around 1940s. Then the actual term of artificial intelligence was coined in 1950s. From there, we kind of followed with recommender systems, followed by the first AI winter, where the academic funding in the field largely evaporated due to similar hype cycle as maybe we see today. This kind of went back a little bit with a successful pilot of a first self-driving car in the 1980s, which was followed by a massive increase in the data available due to the World Wide Web, right? Where all those websites and devices started producing massive amounts of data, which then can act as a source for training the machine learning models. In 2000, we saw emergence of deep learning, and with innovations like backpropagation, those algorithms became way more efficient in actually dealing with this data. So as opposed to some times previously, we didn't really have the technologies or the data volume or the hardware to make some of those algorithms work. 2017 was a big breakthrough with the transformer architecture being published. So this is the neural network architecture that is kind of a foundation for a lot of the large language models right now. Specifically, the paper called "Attention is All You Need," due to focus on the attention layer within the transformer that kind of lets you understand the context within the text, as opposed to just doing simple string matching and things like that. And this kind of brings us to the area that we're in right now. A lot of tech companies and academic institutions are kind of riding this wave from those innovations from the past to basically make new products or new open source tools. So in terms of what we can do, right now with AI. Some of the very classic stuff like classification, regression, but also more interesting use cases like summarization of text, personalization of digital products, advanced stuff like speech recognition, object detection, etc. And for people who are very new to this field and who think that Gen AI is literally a synonym of AI, that's not very true, because the field of artificial intelligence is this kind of broader area which encompasses a number of subsets, right? So the first kind of smaller subset is, obviously machine learning, so data scientists in the room obviously work probably a lot with that. It's basically about, ability for the system to learn from your data and kind of make decisions without any kind of rule-based system, right? A subset of this is the family of deep learning algorithms. So basically, your algorithms are kind of loosely based on the design of the neuron and kind of deep learning architectures. And within that spectrum, we specifically have generative AI. So we can use deep learning for generating new content, either text, video, images, etc. Feel free to interrupt me at any point in time if you have any questions, by the way. Cool. Someone put hype on word cloud, which I 100% agree with. This is the latest Gartner hype report that you guys might be familiar with. The reason why it's 2023 is because 24 wasn't released yet. But you can see Gen AI kind of at the peak of this hype cycle. I think now we probably maybe past this kind of higher stage a little bit, but we're still quite high on the spectrum in terms of overinflated expectations. I think this picture kind of summarizes the state of a lot of decision makers in organizations about, oh my God, ChatGPT is amazing. We need to have our own ChatGPT. We jump for Gen AI straight away without necessarily addressing some of the more important underlying issues, such as data literacy of your staff, infrastructure to actually run those solutions on, data quality, right? And that kind of leads us to another famous statistics from Gartner again, that around 85%, sometimes people say it's even more, of AI projects fail to deliver. And there are a number of reasons why this happens. So first of all, poor data quality. You may have heard this phrase called rubbish in, rubbish out. If your model takes in garbage data, doesn't matter how smart it is, like you're not going to get great results. With some models, it's actually even more important for you to have high quality data, how you curate it, and your model could be something as simple as logistic regression or something like that. The need for designated IT infrastructure. So even if you're talking about Gen AI or classical machine learning, there's some infrastructure needed to run this stuff. So with Gen AI, we talk about stuff like vector databases for RAG or specialized hardware for making inferences. Same with deep learning or machine learning. If you want to have a high performance system, we may need some instances with either GPUs or special inference type of infrastructure. Challenges maintaining AI solutions. People might be familiar with the concept of data drift, where if you train a model today, the distribution of your data may change over time, and this will basically deteriorate the accuracy of your model. So you have to account for this when you build the solutions. It's not like you can build a solution once and you have this artifact of a model forever. You have to keep updating, keep monitoring, keep checking if it works. And it's the same case when it comes to classical machine learning, both to generative AI. You may have seen on the news a lot of recent stories about some scandals where a chatbot may have replied something made up to a customer, like a policy that doesn't exist, to refund the order or something like that. Moving on, shortage of talent and right skill set, both within classical machine learning and AI, but also Gen AI. Generally, there's not so many people who know how to do this stuff hands-on, and companies really struggle to with this problem, and also upskilling existing employees could be a challenge as well. So, as I said, I work for a consultancy. We have this concept of foundation capabilities that basically try to address some of those issues that I talked about. So we have this framework of 6 foundation capabilities that we think are the core things that the organization needs to address if they want to do AI properly. So starting from technology, starting from strategy and roadmap, you have to have a clear definition of the use cases and what value they bring within the organization. If you just do AI for the sake of doing AI, you're probably not going to get a lot of ROI from this, right? You have to make sure that you focus on the most important things that bring you the highest return on investment from using AI solutions, while also considering ethics and making sure that this fits with your operational processes, doesn't impact anyone negatively. Second of all, technology, right? You need to use the right tech stack to be able to do this. It's hard to do AI in Excel. You probably need some, specialized languages and frameworks and cloud platforms to be able to do this. Moving on data, data quality, data infrastructure, mitigating bias and data privacy are some of the key important things when building AI solutions at scale. Delivery model, okay, great. You build this AI POC, but how can you make it reproducible, right? So you can build hundreds of them, right? You have to think about it from the project manager's perspective, like how do you reproduce this whole process? Talent, obviously, hiring, making sure you train your people with the right skill set to be able to do those things. And adoption and scaling. How do you embed this within your existing operational processes? So you get the buy-in from the people who are the end users of the solution, but also this brings the most value to your business. So briefly about Credera, we deployed AI solutions in some of the most challenging environments and highly regulated environments like UK government, US government, pharmaceutical sector, financial services, and some of the, of those companies here. And we have over a decade of building different kinds of AI solutions. It's not only Gen AI, but also we did stuff in machine learning, optimization, anomaly detection, generate images, generate text, MLOps, and AI strategy as well. So enough on the sales pitch. I'm going to jump to the meat of the presentation, which is the key trends in AI in 2024. Starting from the first one. I know a lot of people said that it's just another current hype, but from working in consulting, I can see that there were previous high cycles, for example, with blockchain, NFTs, all that kind of stuff. And we didn't really get so much demand from enterprise clients to do those kind of things. Whereas there's really a lot of demand from enterprise clients because they see the value of doing this, either because they have loads of text data or loads of unstructured data, or they want to do RAG, or they want to have a chatbot for a specific use case. So I feel like this time is slightly different. You can see it from the actual industry adoption right now. So Klarna is just one of the examples where Gen AI is a common use case in customer service. Instead of having some dumb version of a chatbot or a customer service advisor that they have to obviously pay the salary for, they use Gen AI to kind of act as the first line of support, and they already see existing efficiencies in there. There's one downside to this. This is a post from my friend who runs a startup. Companies start to embed Gen AI solutions as part of their existing processes, and sometimes they overly rely on specific vendors like OpenAI. So unless you're able to hedge your risks in terms of maintaining your critical process, like you may struggle. One last thing on this chart, I want to say all of the images on the next slides are generated using Gen AI, so forgive me an occasional third leg. Next one, multimodal Gen AI agents. It's a big trend right now where previously, decoder-based transformer models were only dealing with text, right? So text in, text out. One language in, translate to another sentence, or Python code translated to Java code. We see an emergence of multimodal models where you can pass different formats into it. So for example, you can pass images, video, text, etc. And the model is able to essentially understand what is it. So some of the prominent examples of models like this right now is obviously GPT 4.0 or Gemini 1.5 that you can run on GCP, and you can ask questions about, let's say, a YouTube video. Next one, we see an increased popularity of both smaller language models, but also open source advancements. We're just talking about this with some colleagues here today. There's a lot of open source models that you can access now from GitHub that you can download, inspect the weights, fine-tune them, pre-train the model and do all kinds of things, and you have full control over it, as opposed to like a closed system that maybe OpenAI would offer, right? Another thing is smaller models. There are some academic papers now that suggest that in some cases this kind of brute force trend where your model generally becomes more accurate if you just increase the number of parameters is not always the best thing. And a good example of this would be Bloomberg GPT, where it's a slightly smaller model, but it's fine-tuned on the financial data from Bloomberg company, and this actually performs better than some of the bigger models out there. So some examples of like prominent models in available open source, could be Llama models family from Facebook, Grok from X, Falcon, and Bloom. So each of those models you can actually download on your laptop and kind of run with it. Another one, shortages of GPU and cloud costs. For people familiar with training machine learning models, we know that training deep learning models is way more efficient on specialized processing units called GPUs. Those were originally designed for computer games because they can perform basically matrix multiplications at very fast speed, and they can parallelize them. And even though they start in computer gaming, this is a really good use case for training deep learning models, because in essence that's what you are doing in deep learning. You do different transformations of matrices. Those are not really produced fast enough. There's a shortage of stuff like metals that go into it, or companies that produce them. There's not so many that can actually do this stuff, and as a result, the prices of those GPUs for either buying them directly or renting them by a cloud vendor are quite expensive. So just to give an example, training the previous GPT model was more than $100,000 million. I don't know how much the latest GPT model cost, but it was probably more than that. This last quote probably gives you an idea of the intensity of the problem. Another key trend that I'm particularly excited about is the emergence of new functionality within LLM space, which are basically generative AI agents. So large language models at the kind of transformer paper origin, they were not really designed to do the kind of stuff we do with them right now. They were designed to do translation from one language to another. But we kind of keep discovering different stuff you can do with it. And one of them is basically the ability to create reasoning agents that use a language model that you can make different decisions, and you can give it access to different tools, like an API, like a Python function, which the agent can use when it thinks is the right decision to do so. For example, use a language model and you want to build like a booking system where you can talk to it, and it's going to have an ability to book a flight to you, or book a hotel, etc. Some of the common frameworks now used for this to actually do this hands-on are, for example, Llama Index, Crew AI, where you can build crews of different agents that can interact with each other to accomplish a task that you pass to them, or Autogen from Microsoft. Another thing that we see now, previously doing retrieval augmentation generation. So for people who may not know, what is this? This is basically when you ask a question to your large language model, your chatbot, you want it to give an answer that is grounded in truth, that is grounded in some data that you may have provided, like a link to a website or some internal documents that you pass to it, right? So that's kind of the essence of RAG. And in terms of how it works is that you have to put your data usually in a vector database, where you basically have to transform your text data into vector embeddings. And then when the language model calls to it, looks for like semantic similarity between what you're asking for and the potential content with this vector database. And that basically allows you to the models to hallucinate less. So basically made up stuff less often. And in the past, you kind of have to be quite skilled to be able to do this. Like you need to have to deploy your vector database. You need to probably use LangChain to connect all those pieces. And we see that a lot of cloud vendors now offer those kind of solutions out of the box. So either cloud vendors or startups. So like AWS Bedrock is one example where you have something called knowledge bases, which is basically a way of doing RAG, or GCP does the same. So there's probably less headache to do it yourself, and you can be much faster if you want to do RAG. Regulation, copyrights, and ethical concerns. It's a really big field about how Gen AI would change the world we live in, both from perspective of job protection, intellectual property protection for stuff like artists' work or code bases, etc., and other things like things focused on data privacy of individuals. The EU AI Act was one of the first documents that was issued in this space to address some of the concerns that we currently have in terms of protecting individuals from abusing those kind of technologies. So for those who haven't read it yet, I will recommend it. And the last one from me, which is also quite exciting, is the emergence of text-to-video models. This is a GIF from the famous Sora model published by OpenAI, where you can basically generate short video clips that look very realistic. You can look at even the shades and reflections in this puddle or the way the snow falls. It's really amazing. If you wouldn't tell me that this was generated, I would probably never guess. And I think this is quite revolutionary, and those models are becoming more powerful every year. I feel like this is really going to affect the entertainment industry in terms of creating new content and kind of cost savings on producing new content. So yeah, that's in essence my talk. Hope you enjoyed it. Let me know if you have any questions.
So thanks very much for having us. So myself and Ariadna, both machine learning engineers in the data innovation team at Natwest Group. So yeah, we wanted to talk a bit about how we do MLOps at Natwest and some of the value that's brought to the bank. So on the agenda today, first I'm going to talk a bit about our context as a large bank and what that means and how that shapes how we do MLOps. Then I'm going to talk you through our data science platform that we built in partnership with AWS. So that's really the backbone of our MLOps best practice and how we speak a common language across lots of different teams. And then I'm going to hand over to Ariadna, who's going to talk about all the different tool sets that we use for everything kind of around that data science platform. So things like experiment tracking, evaluation, monitoring. And then she's going to zoom in a lot more on LLM evaluation in particular, so something a bit more new and shiny. The rest of this is a bit of an older talk. So yeah, our context as a bank. So this slide basically is sort of what I want you to get from this is we're a really large organisation. So loads of staff, lots of different departments running lots of different types of models with the UK's leading business bank. So we just have so many customers, so many different types of data, many different franchises, and it can be really easy in such a large organisation to get into a state where everyone's doing different things in different places. It's not very consistent. And we really want to avoid that when we're thinking about sort of model and data governance. It can make things quite tricky and mean that we're not doing things reliably enough. So where does MLOps come in? So first of all, what is MLOps? So it's basically a set of best practices that you apply across the whole machine learning model lifecycle, so that you can sort of all the way from design to maintenance once you've got something deployed into production, so that you can run these solutions in a robust way, a scalable way, and that the road to get them into production isn't too painful. So it's kind of builds on DevOps, but the big difference is that you also have not just the code for your machine learning solutions, but also models and data, and that adds quite a lot of complexity when you're thinking about how to maintain them and how to scale them. So that's what MLOps is. So why do we need it, and why did we start to think about it at Natwest? So before MLOps, I think this, a lot of the foundational capabilities that Konrad had talked about are kind of ones that we've mentioned here. So in terms of people, we didn't have, it wasn't easy to provide the correct training because we had so many different ways of productionizing data science models, and we didn't have consistent processes. Very hard to try and train people for that. Operating models weren't consistent, and then our processes often involve quite manual handovers. So you might have a data science team who builds a model, and then they hand it over to a completely different team who would productionize it. So there's a bit of a disconnect. They don't have the full context. So that can lead to issues. Governance was quite tricky to navigate, and it just generally took a very long time to get from having your model ready and you're happy with it, you're happy with the performance, to then actually using that model to provide some business value. Data discovery was really tricky to know what data you had, and then also how to get access once you decided what data you wanted to use for a data science project. And then we had lots of different environments that people would do data science work in. So they were quite out of date. There weren't really clear routes to live in those environments. So again, teams couldn't really do anything consistently. So at the start of our sort of MLOps journey, we defined some metrics that we wanted to improve on, and these would help us see if we've improved these metrics yet. We think we've done what we needed to do and what we set out to do with introducing some more MLOps best practice. So where we were is up on the slide. So about 12 months for end-to-end solution delivery, which quite slow. So that's from designing a model right through to productionizing it. Access to data could take around 5 days, which is obviously really long, quite frustrating. You can't move very fast. The route to live itself, so once you were happy with a model and you wanted to productionize it, that could take even up to 6 months, so a really long time when you know what you want to productionize. It was just navigating all of these difficult processes. And then environment creation was a real pain point, so you didn't have one consistent way of setting up environments. It meant that if you wanted a place to do data science work, you would have to speak to some platform team. They would create sort of a custom set of requirements for you and then put that in place, and it would take over a month in some cases. And then we had lots of different ways that people were running models in production. So after quite a bit of work, the data science platform that I'm going to talk about in a bit, and lots of other sort of introducing good practices and training, we've got to a point where end-to-end solutions are now less than 3 months. Access to data really, really quick and much easier. You can do it for a team at once who are working on a project. The route to live itself is so much quicker. I think this is something that I experience now as a user of the platform that we built. So it takes less than 2 weeks to move a model into production, which is really great. And then environment creation as well is sort of less than 2 hours, so I'll talk a bit about that in more detail. So you can see that this has really provided quite a lot of value for us in terms of the speed that we can move at. So the data science platform I mentioned, this is built in partnership with AWS, so we built it in-house, but with AWS acting as a partner. And the whole idea behind this platform was that it would provide a really consistent route to live, so everyone would know exactly what to expect when they were trying to move these models to live. And I'm going to kind of whiz through this so that you've got a bit of understanding of the environment that we work in when Ariadna talks through it. So this orange box is representing a shared account that a platform team runs. We have AWS Service Catalog set in there, and AWS Service Catalog basically has a load of different infrastructure, so you can set up infrastructure templates that then each use case team can provision a version of that infrastructure for themselves to use. So it's a nice quick way to get people set up and working self-service. So when a team comes along, they want to start a new project, or they've got a team who wants a set of accounts to work in, they'd first of all speak to this platform team, fill in a form, and basically get these 3 accounts set up, provisioned automatically with Terraform. Once you had those accounts set up, you start off with a team lead, would use the service catalog to set up SageMaker Studio, so a domain and users. Once they've done that, then basically you can start working in SageMaker Studio as a data scientist. So we make heavy use of SageMaker projects, which have templates, so templated code for machine learning pipelines. So data scientists could just start up one of those projects, start working in it, and then once they get to a point where they've built some training and inference pipelines that they're happy with, you can then register those models in model registry, get them approved, and then move them into the test account for testing with a CI/CD pipeline that again is come from service catalog. So all of this is really automated and it's really consistent across every account. So every team really who's doing data science work is using their own set of these three accounts, and everyone can speak to each other and help each other with the process. And then once you're happy in the test account, you can also use a similar CI/CD pipeline just to move the models into production. So much simpler process, and then from there you can start using those predictions for actually getting some value. So a bit about the purpose of each of those environments. So you can see from this it's really heavily weighted towards dev. You're going to spend most of your time in that dev environment. So you'll have SageMaker Studio, which means that you can do experimentation in there for a start, so you can use notebooks. But you can also then use these project templates and build pipelines, so sort of more containerized code. Once you're happy with that, as I mentioned, there's a model registry, and you can also create images that you'll then use in the test and prod environments. Test and prod themselves are much more stripped down, so test is obviously like a replica of prod, and all that you have in there is inference pipelines and models just for you to test before going to production, and the same thing in production, so no SageMaker Studio in the test and prod environments. And then what this looks like for a user, so say a data scientist working on a project, they'll go into SageMaker Studio, and they'll, with a few clicks, click on this Create Project. And with that, they'll get a few different things provisioned. So this all works with the AWS Service Catalog again, but it's done through SageMaker Studio. So the data scientist never really leaves this IDE environment that they're gonna work in most of the time. So they get some S3 buckets provisioned, some AWS code pipelines. So I mentioned the model promotion pipeline. We also have other pipelines for running SageMaker pipelines as well. Lots of pipelines. There's a template code base. So that gets copied into your empty Git repo that you've set up, and you can start working on that. So it's quite a quick and easy way to get working. You're not starting from complete zero when you want to build something. And then from there, you can start to edit that template code base, and this is just an example of what a pipeline would look like in SageMaker Studio. So you'd have a graph like this that you could see for pipeline runs, and then edit and run those until you've got something you're happy with. Once you get to that point, so the model promotion process in detail, so you've had developers updating the templates in SageMaker Studio. They've used the model registry to register those models, and they've run some CI pipelines to check for things like run unit tests, linting, formatting, etc. with AWS code pipeline. So from that point, then the technical lead can carry out the model promotion, and that again is an AWS code pipeline from the service catalog. So they will do that. They can only go ahead with that once a model approver, who's a separate role, approves the model in a model registry. When they go ahead with that, then you get the models and the inference pipelines in test, and then the same pipeline used to put them into prod. So that's kind of a whistle-stop tour of our data science platform. But surrounding that, there's lots of other things we still need to consider that I haven't really mentioned there. So that's the basis for it, but I'm going to hand over to Ariadna now, who's going to talk a bit more about those tool sets.
double, if that round button on. Yeah, okay, you're on mute now. Awesome, thank you. Sorry about that.
It's okay now. So thank you, Lucy. So Lucy just walked through all the processes that we are following in our platform, and we managed to modernize our tech stack and standardize all these patterns. But also we create a community and ways that everyone can learn from each other. So that speeded up as well the learning of people, and that is helpful like for this skill set that everyone can get. But also it's important to remember that we are a bank, so we have to be careful with our customers. We want to be fair, and also we have to comply with the regulator. So we need to have some tool sets that can provide the support to the capabilities and governance and risk management. And that's why I'm going to talk about what we are using through all the process, from the data discovery to all the way to the productionization. So some of the tools tools that are supporting this is going to go all these first stages where the data scientists will explore data sets and then start doing their first models. Well, one of the tools we use for experimentation and quickly is Comet. Comet is really easy to use. Just run some lines of code that the data scientists can embed into the code, even notebooks. It could be also the pipeline scripts. And basically, it's also registering the models. So when they run this, they can just log all of these experiments, and it has an easy UI where they can just try to select the best model that is in purpose of the use case. And once they are refining some of these models, they just pick up the best to go to the next stages. And for that, for example, we need to run some model diagnostics. And we can use SageMaker Clarify because we want to be ensured that we understand the predictions of our models. If the regulator comes and asks why to grant this decision to this person, we need to ask why. So we use SageMaker Clarify for the model explainability and bias detection in the data and in the model. And that is really useful along the first stages until the next stages, so just to refine and make that diagnostics. And now in the world of the LLMs, so of course we need to have another tool. We are using the open source tool called TrueLens. That in this one, because it's an open source, something that comes in, and I will explain in the next slides, is that you can define your own evaluation metrics. But also you can use the out-of-the-box of this. And when you are building a new LLM application, you want to iterate fast and also manage the risk of the responses of your LLM. And also in the final stages, you want to use the monitoring. You want to ensure the health of your product. And we use SageMaker for that, also for monitoring the data quality and the data drifts and the bias that can come. And I think, as our speaker said, like, we need to keep an eye how it's performing. It's just not one solution that you have for one day. You have to see how your model can degrade with the time and set up alarms. This SageMaker has some alarms that can notify relevant people that can go investigate, and they can mitigate what is going on with the model. So now we're going to focus about our LLMs and TrueLens. So basically, TrueLens is a tool, open source, and you can build a LLM application that has a framework of LangChain, Llama Index, or Python. It doesn't matter. You can connect to your code some lines from this library, and it's going to start logging some records. Then you can use what I'm going to explain a little bit, a feedback function that is going to be the evaluation you're going to use for the responses, inputs, outputs of your LLMs. And then it has like a dashboard that will help you just to understand the different versions of the different applications. In this case, they are calling change versions. And then from that, select, after this iteration, the best version that you need. So the TrueLens comes with out-of-the-box feedback functions. And the feedback function is a way of doing programmatically, like it's a wrapper function. And it's not like, it helps you in a way, having a more consistent approach instead of going to look by hand or checking like spreadsheets, CSVs and stuff like this. So it gives you the programmatic power to do it. And it's, as I said, checking inputs, outputs, but the feedback function that comes out of the box can come from check how honest your application is, how harmful the application will be, and how helpful you are finding it. I think also in our previous speaker, we're talking about the RAG, that basically is retrieval augmented generation technique that is preventing the hallucination. So in this one, the context of what is happening is that you provide a context that comes from external data sources to your LLM along with the prompt and the query you want to have, or you have, and you send it to the LLM, and the idea is that the LLM will have an enriched understanding of context, so it provides you a more relevant answer. In this one, we have 3 different metrics to evaluate this RAG triad. Is made of the context relevance, that is going to check how relevant is the context that is retrieved by the LLM. And then we have the groundedness that is going to check how much the response is supported by the context that was retrieved. And then the last one is the answer relevance, that is going to check how relevant is the response of the LLM given the original query. So having this in place, we're going to show today one small demo about TrueLens. It's a notebook. So here in this notebook, we are just plotting like some of our libraries. We're going to use Azure OpenAI. And also we're going to have use the TrueLens evaluation feedback functions. Here I'm just having one of them. We need to have a .f evaluation, .f file with all our environment variables because they should be hidden. And then we are going to load it with this library, .environment. So we are just calling those environment variables that we need to use it for requesting access token. And also we're going to initialize our chat client. In this case, is the ChatGPT 3.5. We're going to create some data, like some documents about universities, students, and club info, for example. And then we're going to inject these documents in a vector store. Here is a ChromaDB, it's an open source. And we're going to pass the embedding of those files. And we're going to use semantic search. By default, it uses a Hugging Faces model, but we can use embeddings from our ChatGPT 3.5. And you can use a distance metrics. The default is going to be the cosine similarity, but you can also define other ones, like L2. Here we're starting our embedding function, and then passing our vector store, starting a new collection, and passing which are the embeddings we're using for those documents. Then the documents will be passed in a list. At the same time, also metadata, and some other, like IDs that you want to store as well. Now we're going to start our RAG evaluation. We're going to start our instrumentation from TrueLens. And it's going to create a SQLite database just for our dashboard that we're going to show. The RAG, this is a RAG class we are defining. With the instrumentation, we have this decorator. We want to start the retrieval process. In this function, here we are generation and completion, where we are passing our prompt with the context. And at the end is where you just define a function called query with the query and calling the other 2 functions. And then we're going to start our RAG instance. So again, here I'm just saying a little bit about what the feedback functions, like I say, it's a programmatic way just to wrap our evaluations. And it doesn't need to be just for LLMs, but it could be also for rule-based evaluation approach. And it is because we are not having a grand truth of what the LLM is going to respond, but we can try to devise some of these evaluation and using sometimes, in this case, other LLMs for that. So we have to set up here our feedback provider. We have TrueLens with different providers. Here's OpenAI. I started our one of the instances of one class of groundedness. As I say, we have this 3 triad. And so we're going to start the groundedness triad, and we're going to record every call for every retrieve for every of our answers that we're going to get, and it's going to be the same for the other the two metrics. Then here we're going to start our app, our TrueLens app, where we're going to pass our RAG class, and as also the name of the application and the 3 different feedback functions. Here we are having some questions. They will be in a spin read this question and create a list of all of these questions. I'm going to show you in a bit. And then we're going to iterate with a for loop just to start recording those questions and checking how it's evaluating with TrueLens. Here we can visualize everything in the notebook, but also like this is like the aggregated value of all those queries. But we can have like a data frame, but this is not easy to dig or visualize. But you can use it for other aims if you want to store it in a database for other visualization. But you can use as well this start a server, what is going to bring this TrueLens dashboard, where we can see the same details like summarized here. Also, we can check the total cost, the total number of tokens, and also the aggregated value of all the evaluations. But we can also look at the individual questions we made and how it was evaluated. And we can have also the other metadata to be shown. But we can always go and check, for example, what was the input, what is the response that we are getting for the LLM. We can just check other ones, other of these calls. But also we can explore, for example, here in the context relevance, what is the statement that was given, and what is the reason that we got this score of 0.9. The same for the answer relevance. We check what is the response, what is the reason, and we can just try to understand what was the reason for giving a good score. In the groundedness, we see the source, the statement, and here we're going to see the statement, but also a score. So this is just for us to show you like a flavor of how you can work and use, these tools. Give me a second. But also we have to acknowledge that there are a lot of challenges and a lot of things we need to take into account. So it's important to have this quick experimentation because we are ensuring the security and prevent harm. We can have data leakage if we are not doing these exercises. We need to look that it's fair, that it's not toxic, even we give a benign or adverse settings. So we need to look and be sure it's not going to be harm for our customers. Also, the adaptation, how it's challenging to adapt in an evolving field, and also where they are not standardized patterns to follow, and also where the models are changing every time. No? So we need to keep ongoing and learning. Also, standardizing the evaluation is a little bit hard as well because you have some, for example, in the RAG, is the LLM judging another LLM, and you have to create some prompts. So we can have a groundedness metric, but every business could have their own, or every use case their own ways of defining it, and also the ways they are defining the scores. So as well, we need to check like how it's going to change that evaluation when from ChatGPT 3.5 ChatGPT 4. So we need to keep like maybe it's going to be changing and make a statistical analysis because this is stochastic parrots. Also, something important, how we can enhance the performance of our RAG evaluation. So we need to maybe to have different retrieve techniques. And I think our speaker also talked a little bit of that. But for example, the bank wants to build their own solution. We are really concerned about who's touching our data. Also, you need to know your pipelines and do better prompt engineering to be able to understand what is going on with the answers of your LLMs. But we just wanted to give you that context of how our platform works and how we are starting implementing a little bit of these open source tools in our work with our colleagues. But if you want to go more in depth about our platform, we invite you to go to our AWS blog series, and you can reach Lucy and me whenever you want. Thank you.